Okay, guys, here we go. This pre-calculus 9-3, homework page 631. Okay, we're talking about geometric sequence and series. Sequence, series, they're the same. The only difference is sequences have commas, series have pluses or minus signs in them. We're going to try to find the terms and the sums of geometric series. Okay, a geometric sequence is a pattern of numbers with a common ratio. So we're multiplying to go from one term to the next, okay? an equals a1 times r to the power n minus 1. The sum formula Sn equals a1 parentheses 1 minus r to the n and all over 1 minus r. Now this is a unique case, okay? Infinite geometric sum. All right, you can only use this when it's infinite geometric sum where absolute value r is less than 1, okay? So this is finding the sum of all the numbers in existence for that series and sequence. So let's do some examples. For example, here, let's say, here's my pattern numbers, right? I have 21, 4.2, 0.84. So what I notice is that here I'm multiplying by 0.2. Here I'm multiplying by 0.2. So that's going to be my r. R is going to be 0.2. Okay, I want the sixth term. So again, a n equals a1 times r n minus 1. That's all. So the sixth term is going to be the first term, 21 times 0.2 to the 6 minus 1. So a6 is 21 times 0.2 to the 5th power. Okay, so all you gotta do is multiply that out. Okay, so 0.2 to the 5th power. Okay, and now you're gonna times that by 21. Okay, so this gives you the sixth term is 0.00672. That's it. That's the sixth term. All right, so another example we might have is for, let's say, let's say I have something like 5, 15, 45, 135, and on. Okay, I want to know what is a tenth, S8. Okay, a tenth just means I have first term 5 times my ratio. If you look at my ratio here, the ratio is pick any term and divide by the one in front of it. For example, 135 in front of 135 is 45. Okay, that's 3. Or I can do 45 divide by the one in front of that, and I also get 3. Or I can do 15 divide by the one in front of that, and I get 3. So the ratio is just pick any term and divide the one in front of it. Okay, so in this case it's 3, 10 minus 1. So a10 is 3. Now, 5. Now make sure you do order of operations first, okay? 3 to the 9th first. So 3 to the 9th. Okay, so 5 times 19,683. And so the 10th number is 5 times that. You're looking at 98,415. So that's it. Now S8 next. S8. Okay, so the S formula, Sn equals a1, 1 minus r to the n over 1 minus r. So this one inside the parentheses has an n. So first term is 5, 1 minus r is 3 to the 8th power. Now notice this one, we're not subtracting anything. Okay, 1 minus 3. Okay, so 5 parentheses 1 minus 3 to the 8th power. Okay, that's going to be 6,561 all over negative 2. Okay, So when you compute all that out, you get 16,400 total. There you go. Okay. Hopefully you're able to do that. Now there are some unique cases of infinite geometric series, and you want to find the sum of them. So for example, okay, let's say you have 16, okay, 8, 4, 2, 1, on forever. Okay, so R is going to be pick any number, divide by the one in front of it, like 1 divided by 2. Or you can pick 4, divide by 1 in front of that is 8. So that's also 1/2. Okay, now here I want S. Now this is infinite. In other words, it goes on forever, and the absolute value of my R has to be less than 1, which it is. So what I can do here is find what's called the total sum. So just S, no particular number here. So S, okay, the infinite sum, they call it. Okay, I'm gonna find every number added together. So it's a simple formula, A1 over 1 minus R. Okay, so I'm gonna add every single number in existence here. So S is 16 over 1 minus 1/2. So 16 over 1/2, 32. So what this says is that if I take every single one of these numbers, every one of them, all of them, added together, I'll get a grand total of 32. Okay, every single number here added up will not surpass 32. It is not possible. Okay, so hopefully you're okay with that. So let's do another example here. Let's say we go with, well, let's go with, let's see, 60, 24, 9.6, 3.84 plus dot dot dot. Okay, so R is pick any number, divide by 1 in front of it. Okay, 9.6 divided by the one in front, 24. Okay, so what you'll get is 2/5. Or if you do 24 divided by the one in front, 60, you also get 2/5. Okay, so notice here R is less than 1. So I can use and find the S. Okay, find the total sum. So 60 over 1 minus R, 2/5. So S, the total sum is 60 over 3/5. So looking at S equals 60 times 5/3, right? Reciprocal. And you get 100 here. Every single one of these numbers added up will have a grand total of 100, okay? So have fun with geometric series. See you later.